So in this final section on bootstrapping appropriate behaviors, I'd like to start with the significance of imitation and then go on to some summaries of the conclusions we reached. Imitation is a critical element in bootstrapping appropriate behaviors because it's an easy way to initially define the circumstances in which behaviors should be rewarded. It provides a way around the problem that an external supervisor can't access the internal wiring of the brain. Although anyway, the lack of correspondence between receptive fields in the teacher and pupil brain would make such direct access very hard to use anyway. But imitation just uses information about the overlap between different column populations in the pupil's brain to generate appropriate reward behaviors. It doesn't require any information that isn't available to neurons. Hence, imitation is of critical importance and turns up in all sorts of different behaviors as a way to enhance learning. So now let's have a look at some general points about genetic guidance. Although some degree of genetic guidance is needed to make learning feasible, it comes with a cost. It will limit the flexibility of learning. It's perfectly possible for genetic information to control behavior very specifically. In the case of spiders, the form of their webs is specified genetically. There are strong similarities between the webs of all spiders of the same species, even if the spider was hatched from its egg and matured without any contact with any other spiders. However, there is a bit of learning from experience to adjust the web to a particular site, to adjust to wind direction and so on. Even brains with much more learning capability can have some behaviors closely controlled by genetic information. Most birds build nests so specific that at least the genus of the species can be identified, and studies of weaver birds, for example, show that they build intricate nests of their species type even if they were hatched and raised in isolation. But of course, this kind of detailed specification means that it's less possible to learn better options through experience. In human beings, there's probably a lot less genetic specification, and that means the learning process takes a lot longer. But even so, there has to be some genetic guidance. And as we discussed, the type of guidance tends to be more general, levels of receptive field complexity in different cortical areas, types of behavioral components in the basal ganglia and their initial connectivity, some initial definitions of receptive fields recommending rewards, and so on. Although in some cases it can be fairly specific, perhaps especially for initial definition of reward circumstances, where the impact of learning the wrong things is going to be very strong. And even in the case of bird nests, it may be that the shape of the nest activates genetically defined receptive fields that recommend reward behaviors rather than specifying the detailed sequences of construction behaviors that have to be specified, whereas in spiders the detailed sequences of construction behaviors are probably specified genetically. So for any brain, the appropriate degree of genetic or a priori information is a compromise between behavioral flexibility and the resources needed for learning and the speed with which learning can occur.